Hope everyone is doing well. Can you just write the message to make sure that you can hear me well? Just anything on the.
Yeah, we
Oh,
can hear you clearly.
okay, thank you. Okay, so first of all, well done everybody on the midterm. The average is. Oh, you can't see over here. The average was it 83, 84%, which is actually pretty high for a first midterm. And traditionally, usually the second midterm gets a higher grade than the first one. So we're definitely on the right track here. So I'm definitely very proud of you guys, and especially that this whole online thing is not actually easy. I know it's not easy for a lot of viewers who are at home, especially if you're forced to be at home rather than you choose to be at home. I know it's not easy, but well done, everyone. And I have to say, I'm extremely proud of you. You were able to pull through these very challenging times. Okay, so now down to business. Um, Today's lecture, we're going to continue on with static modeling, which is mainly talking about UML, the class diagrams. And we began this in the last lecture, and this lecture will finish off that chapter. And we'll do a whole bunch of exercises towards the end of this chapter. And if you remember, we looked at the last thing that we looked at was numerical specifications as such. Okay, how we put the numbers to do multiplicities. And with it, we can define one-to-one associations, one-to-many association, many-to-many. Maybe a numerically specified association, like a car has 4 doors or 3 doors or 5 doors. An optional association, usually that goes into the sense of 0 to 1 or 0 to even a higher number. So a customer owns debit card, you can own one, or may not own anything, or own more than one. Then I'm not sure if we actually we covered this. I don't think we did. We have 2 more types of association. The first of which is called a ternary association. Now, a ternary association is a situation where we have 3 classes, okay, and there's an association gathering all 3 classes, okay. Now that means that all 3 are together in this association. So an association that is pulling through 3 things at the same time. All right. For example, it could be something about administration, the faculty, and maybe the students. Okay, all together are, together they're dealing with there's some sort of an association between them. Okay, which is slightly different from something we're going to cover in a moment called association class. But these are 3 separate entities, and they are grouped together through one single association. That's called a ternary association. And matter of fact, in theory, you can actually have as many as you want, 4 or 5 or 6 or different classes, all associated together within the same association. All right. Last up, we have something called unary association, and this is when a class has an association with itself. Okay. Now remember, we're not actually dealing with classes, we're dealing with objects, okay? Which means that what we're actually having is an object having an association with a different object of the same type. And a classical example for that, for example, how students are prerequisites of each, courses are prerequisites of each other. So we're talking about the same class. We're not going to have a class called SE310 and a class called SE225 because they're actually the same type of class. Okay, so we'll write down that we have a class called course, and then we have what we call a unary association. Unary means comes from the number 1, and it's an association with itself. Another example could be, a father-son relationship. We're both human class, so a father-son relationship is a relationship of the human class associated with itself again. All right. Next up is something called an association class. Okay. Now this is the notation you see at the bottom over here. This is the association for the notation for the association class. You'll see a regular association. All right. And then you see the dotted line coming in at the bottom, and this at the bottom over here is what we call an association class. Now, The difference between this and the ternary association, that the ternary association was talking about three separate classes who came together through an association. Now, the association class is a class about the association itself. A classic example of this is, for example, here you are, you're a passenger, and then there is an airplane, okay? And the only thing that is actually connecting you with the airplane is, can you imagine? A ticket, a reservation, okay? Now, that reservation in itself, think of it over here as a class on its own. It doesn't exist unless there was a relationship between the passenger and the flight. Unlike the ternary association, where there's three separate entities that existed anyway, and they just happen to come together for a particular association, okay? In other words, the association class was born out of the actual association. And the whole meaning of the association class is that this relationship between one object and one class and another one, it itself is complex enough to warrant to have its own class. Okay, so passenger and an airplane. Okay, we said it's a concept of a reservation. Now we shouldn't be satisfied by just having a line and saying, well, it's just a reservation, because there's a lot of information that goes into a reservation. Could be this information, could be attribute information, it could be operation information. So the attribute information, obviously the date of the airplane, the flight number, the seat number, the name, and so on and so forth. Some operations could be change or modify the reservation, cancel the reservation, upgrade the reservation, and so on. But again, it's kind of like this association class is talking about what's going on in that association in the middle between the two different classes over there. All right. And it's a bit different, as I said, from a ternary association where I have three separate classes. Okay. And they're all equal in weight. They're not, there isn't a particular class that is born out of the association between the other two. It's just there's three separate. And then we said, like, we're going to connect them, all three of them together through a ternary association. All right. All right. So we said we're going to look at three types of association. We said actually it's four types: association. The next was aggregation. The third is composition. And that's like one branch of the family. And the second branch is generalization, which we are familiar with. Okay. Now, aggregation is a form of an association, but it says more. Okay. And aggregation is what we call a Haza relationship. Okay. The word aggregate means a collection of. It means something is made of a collection of something, or is collecting a bunch of other objects. The notation tends to be a hollow diamond, as you see, and then there is an arrow and a bidirectional, sorry, not a bidirectional, a unidirectional arrow from the parent class to a child class. And this is a good example. So basically, the way I'm reading this, a study pack has a assignment, it has a slides, it has a lecture notes, videotape, and so on. The assignments itself, it has exercises, it has solutions. All right. Now, what is unique about the aggregation is that if this aggregation connection is disconnected, then the parent lives on and the child lives on as well. Okay. In other words, especially from the perspective of the child lives on even if the parent was disconnected from it. Okay, classical example of this, you have a company. Okay, so that's a company at the top, and you got employee. You got employee at the bottom. Right? In case the company, where did it go? In case the company is gone, employees still live on. They can go on and live and work at a different company. So that's aggregation, collections of. Okay. Yeah, if In case you do remove the upper. Now, aggregation has nothing to say about if the upper lives on or doesn't live on. Okay, I'm just saying if somebody comes up and deletes the upper, the lower stays on, and it can then be aggregated as part of something else. Yeah. Okay. Okay. So a college has departments. Departments has maybe one or more research centers. You know, if the college closes, we can take the department, make it part of a different college. Same thing we can do with the research center. Same thing we can do with the faculty or part of that department. If that department closes down, they can go join a different department. They can go join a completely different university if they if need be. All right. So that's the aggregation relationship. Again, it's an association. It's just it's a stronger type of association, and it's saying more than just a simple case of, hey, there is some sort of an association between us. There's some sort of a relation between us. There's a has a type of relationship between us. All right. So again, here you see a college has departments, it has research centers, it has admin, and with an aggregation, okay, you can have zero also. Okay, so it can have like 0 to 1 over here. That's fine. Okay, so it could be part of the collection, could not be part of the collection. That's really up to us. Okay. Um, Next up is composition. Now, composition is going down the same family route as aggregation, except for it's actually a stronger type of aggregation. Okay. And we use it to describe what we call a part of relationship, not just a has a, but rather a part of. I mean, the bond is a lot stronger here. Okay. And if I'm reading this example, okay, I'm reading and saying a room is a part of the house, and the bathroom is part of the house, and the basement is part of the house, and the kitchen is part of the house. All right. Um, the notation, as you can see, it's the same diamond as we saw in aggregation, except for it is filled. Okay, so you can see it's black, and that's kind of like to denote that it's a stronger type of relationship. Now, what's different between the composition relationship and the aggregation is that if we delete this relationship, or for some reason, or specifically, we delete the parent, okay, the children cannot live on. They do not have a meaning in the system without the parent. Okay, so I like to use, yes. We're getting to a completely different meaning. So this is has a, okay. Generalization is talking about, so for example, you're saying man is a type of human. Okay, I'm not saying that human has a man. Okay, yeah. So it's a completely different family branch. Yeah. Okay, whereas aggregation and composition, we're talking about ownership type of relationships. Okay, so this is a classic example to show you the difference between the composition and aggregation. So we had the company, and we have people, we have accounts. Okay, so you can imagine if the company is gone, the people will still live on. They might work in different companies, but account would probably be very, very related and owned by a particular company that that company is gone, that accounts no longer exist. I mean, imagine if you have an account in a bank and that bank ceases to exist, then it doesn't make sense to have that account anymore. It's just, it won't live on the system without it. Okay. Again, it's not saying anything of the parent, whether it's going to live on or not live on. That's a completely different problem right there. We're talking about the children class. Okay. Aggregation means had the parent gone away, then this will live on, whereas the accounts is not going to live on. And next up is the generalization relationship. You've probably already seen the notation. It's the full-on triangle, hollow triangle that you see at the top. All right. Whereas the parent goes at the very top, and the child goes at the bottom. Okay. And I'm pretty sure you're already well aware of the characteristics of the generalization relationship. Okay. It's not an ownership thing. So it's a different family branch. And everything that is true about the parent is also true at the child. But the opposite is not true. Okay. Might have things that is true about it that is not necessarily true in the parent. So a Toyota is always a car, but a car is not always a Toyota. Okay. And as you go up the chain, it's the same thing. And there's also an inverse relationship between the usefulness of an object and how concrete that object is. Okay, so obviously Toyota good is right in the middle. Okay, Toyota Camry is more specific. Toyota Camry Blue is more specific. Camry Blue 2019, it's more and more specific. But then its reusability starts to reduce because next year, 2020, that class is no longer needed. Okay, now if you go up the chain, so Toyota, yes, Toyota's probably going to stay there for a long time. What's going to even stay longer is vehicle. Okay, um, and then what's going to even stay even longer if I abstract that to a point that is no longer logical. I've used an object, a class called object, which is the most parent, the super object of all, but it has nothing. Okay, it's just called object. All right. So is it reusable? Oh yeah, it's reusable everywhere, but it's completely useless to begin with. All right. Everything, it's inheritance. Why the word inheritance comes in the programming community, because when we say everything is true about the parent, it's true of the child. Okay, so all the attributes are inherited into the child. All the functions are inherited into the child. The child can add to it, or it can oh, yeah, omit, override. You should know. Override. Okay. A shower was what? What was the question? I was saying, that the parent and the child inherits everything from the parent, attributes and functions. Okay, a child can add. So you gave me X and Y, you're my parent, you gave me X and Y, I can add Z if I want to. But one thing I can also do is I can override what you gave me. So you gave me X equals 5, I decided to make it X equals 6. Okay, and in my class, if I say print X, is going to print X equals 6. It's not going to print X equals 5. Had I not overridden it and I said print X, it would have printed X equals 5, which is what I've inherited from you. All right. So I'm pretty sure you're very well versed into the concept of generalization. So I'm not going to go into so much details into it. There's a lot of examples, as you can see. But the one point that I'm going to, you can just look at that up at your own time, is the idea of multiple inheritance. Multiple inheritance is rather problematic. Okay, and the reason multiple inheritance is problematic is that if there is some sort of an attribute, say X over here, and there's X over there, right? And I say print X at the bottom, which X am I actually getting? All right. It's funny. It's kind of like inheritance in the real world as well. When you have a child and there's something like wrong with it, it's like, oh, I inherited from you. And then the husband tells the wife that, and the wife tells the husband, no, she inherited from you, and so on and so forth. And good luck trying to pin it on which particular person did they actually get that. Same thing with the good attributes as well. Okay. Oh, it inherited from me. Another person says, oh, it inherited from me, and so on. Okay. Now, because it is problematic, okay, back in the day, when programming was still a thing, was a new thing, should I say, something like C++, it lets you do whatever you want. Okay, you causing yourself a lot of trouble that you're not really aware of, but you're the boss. Okay, came along Java. Java said if you're doing multiple inheritance, chances are you don't know what you're really doing. So multiple inheritance only works if what you have on the left hand side and on the right hand side, in other words, and in the parent classes, are 100% completely discrete. Discrete as in there is no match or any intersection between them. Okay, so as you can see in this example, book has author, edition, publication date, and ISBN, whereas video recording has speaker, duration, and recording date. There's nothing common between. So that would have worked, but you're playing with fire. And Java comes and said, if you're doing multiple inheritance, chances are you have no idea what you're doing. So you can't actually inherit more. That's why when you have the word extends, you can only put one class after the word extend, you can't put more. Now with interfaces, you can implement more than one interface because what you're implementing anyway, what you're getting is something that is empty anyways. So had I had, for example, X over here and X over there, and I'm implementing it, I'm getting something empty here. So there's no worry about what if I print X, what value will it be? Well, I got something that's empty from here. I got something that's empty from here. They're both equal anyways. All right. Okay. Now, I'm going to step away here for a second, and I want to tease your brain a little bit. Let me share the screen. I always make this mistake. Okay. So guys, I said we have the three types of relationships. We said association, صح? Remind me what else was there? Aggregation. Composition. And then finally, and you said colonization. All right. Now, okay, this is kind of like one of these meta exercises, okay? All these four types of relationships, assuming, well, they're not assuming, there are actually concepts, صح? And what is a class? When we say we have a class called student, we're actually identifying a concept, okay? We're actually identifying a concept. So I'm actually going to identify these four relationships as, exactly, Salam alaikum, Osama. All right. What would be the relationship between those four classes? Hmm? Yes. Oh, see, it didn't work. Yes, in a class diagram relating all four classes together, what would be the so I gave you the classes. I'm waiting for the relation. I think, yeah, tell me. I want you to tell me this class is associated with this class is the parent of this class. I want you to give me the details from that level. No, we don't need to. No, just use those four classes. Say what, huh? Aggregation and a composition. Okay, so how do I draw that as a class diagram? You're right. Just, I'm still waiting for the answer, but you're right. You're laughing at my misery, huh? Okay, so you're saying final aggregation. So you're saying grab this. Okay, put that over here. No. I was so close. Let's put it over here. And you're saying this. Is that what you're saying? Okay. We still have one more class. Generalization. I actually I dropped, but 4 or 5 hints as we're getting to this. The family tree. Aggregation is aggregated to the composition. Like no. They have. No, that's not. Okay. But this what we call a childless parent here, a parentless child. I mean, where is this generalization box where we're gonna? If you really understood the concept that I explained, then you should be able to answer this question. And if you showed up on time, okay, this is just an indirect dig at you. Okay, yalla, huh? You were saying gonna say something. No, I was just gonna guess. Yeah, fine, that's fine. Generalization above association, as in, so association is inheriting from generalization. Is that what you mean? Okay. Do you feel like this is right? I mean, if we do this, okay, which one actually is saying more? Association or a generalization? If you have a generalization with someone, are you also associated with it? Yeah. Now, if I'm associated with someone, am I necessarily generalizing with it or specializing with it? Not necessarily. So, huh? I'm giving you the answer. Yeah. So, صح? Yeah, you can. You can tell me. Yep. Now, this is a 90% correct answer, but there is still a small modification. All right. And the modification requires us to remove this because this is not right. Okay. This is half right. What I just erased right there was half right. Salam alaikum. Okay, so the composition is a specific type of aggregation. Okay, and I was saying before, remember I was saying talking about family branches. Okay, this family branch is talking about ownership. Okay, whereas this family branch is talking about specializations and inheritance, which is really the same thing. Okay, that's the difference between the different type. Now, this way you should never be confused between composition and aggregation, and then at least the other branch was a generalization. Okay, because it's talking a completely different language. Okay, we're talking about generalization. I'm saying, so with generalization, that is why you don't actually see multiplicities. Okay, it's sort of like overrides association with this. There's no multiplicities. Okay, all we're saying is that a human could be a man, could be a woman. We're not talking how many men or how many women per se in a class diagram or in actual objects. Okay, whereas with aggregation and composition, yes, we do have multiplicities because they can say a study pack can have 4 assignments, can have 3 assignments. Okay, and also when I'm reading diagrams that has aggregation composition, I'm not reading saying, Allah, the assignment is a type of a study pack, or the faculty is a type of a department. Doesn't even make sense. Funny, when you look at these diagrams and you say it out loud, okay, composition, part of aggregation has a both ownership. So ownership is something and belonging is something, and being a type of something is a completely different concept altogether. You shouldn't be confused. I get it if you're confused between aggregation and composition, because they're both within the same branch. Now, the way to differentiate between them, okay, you take the child object, you cut off the head, the parent, okay, and you look at the child object. Should it exist beyond this? If it's yes, or it can, then it's aggregation, and if it cannot, then it's a composition. Right. Now we're gonna step away and we're gonna do exercises. Fun part. We got a whole bunch of them. Okay, so yalla wara waram. If you don't have a paper, I got it over here. I actually brought this from the last lecture. So please come and let me just put this first. And I can't help you with the pen part though. You have to go get your own pen. Or if you're gonna sketch. And first of all, let me just make sure I share the screen because I'm probably not gonna be doing this right. Okay, guys at home. Do you need paper? Oh, you got this? Osama, you need paper? You gotta write it on the phone, okay? Yes, of course. I don't even need paper. Okay. Where is the? As soon as I say exercise, and boom, everybody just going. All right, so the first exercise. Okay, we got A, B, C, D. We got 5 exercises. And yeah, I know. هنقعد مع بعض هنا حبة حلوة. Oh, you're going down? Oh, okay. I thought you escaped. Yeah. You have something to write with? Oh, mashallah. Everybody's Right. So the first exercise says any person in a hospital is either a patient, nurse, or a doctor. Nurses and doctors are considered staff. Any person in a hospital has a name, address, and a phone number. The hospital has departments, and each department has staff. Yalla. I mean, working together, you mean? No, no, everybody on their own. Well, why not? I don't mind if you work together. بس خلينا for now separate. Kind of like to force you to think. So you see a lot of the keywords is a, has a, you know, that should give you a hint. خايف منه. Mhm. So the diamond is on the other end of where the arrow is, صح? And the arrow is basically showing one class pointing to another. So it's who needs who. Okay. Always think of this. Okay. So if a company has people, all right, and those people can live on without the company, so who needs who, right? That's the sort of thing. Yeah. But even when you think, for example, like say human and heart, a heart, if you take away the human, then the heart doesn't live on. But still, the arrow goes towards the smaller component. Okay. Yeah. Okay, guys, can you take a picture of the? I think it's already on your Moodle, anyways. Because I need to run get the charger because I forgot it. Get the charger and come back in. Just take a picture of this so you can read it. And guys at home, it's probably gonna disconnect for a few seconds. All right, because I need to go get the charger from my office and I come right back. Do you take a picture? Huh? Anin? Got it. Okay. I think it's on Moodle. I think it's on Moodle, so? Okay, so guys at home, you can find the same exercises on Moodle, except for obviously, I have some white space so we can answer it over here. I'll just gonna, it might pause the, yeah, it's called static modeling exercises. It might pause the Zoom session, but it will reconnect immediately after, but I have to lock the screen. Okay, I'll be right